And we start off this time with a code that actually does something and is already existing. So our HTML file is going to first be more user-friendly. I'm using this viewport meta that I got advice that I should use yesterday, but student is not here. I forgot his name. But anyway, so yes, more mobile-friendly. And then I'm using a library called Three.js. This is a library built on top of WebGL. So in that context, we used to use in VVD course and also yesterday. It's also possible to initialize it instead of 2D with WebGL. And then you can draw coordinates and everything in 3D space. The problem with that, trigonometry and mathematics become so difficult that we would make this application in it probably until next week, but hopefully this week. So there are so many complicated functions there that explaining everything is just too much. So I'm going to use it to help me get this application more useful. So I highly recommend using some external library if you're going to make 3D apps in the canvas. The library has a nice page here with very many different demos. They are really nice applications. Some of them are games, some of them are just animations or visuals. One I just clicked before and it seems to work is this Rubik's Cube game. You open the interactive version from here and well, it starts off like this, and then you can actually play it and you can move each individual part here in the browser. If you don't own a Rubik's Cube, then this is some alternative. It's actually almost nice. Like, of course, it's really nice, but the problem is sometimes it moves something that I don't like it to move. So I think that the user interaction could be somehow done better, but I don't know how to do it. So I just complain. Anyway, this is a nice one, and there are many of them, so you can check them out what is possible to do in the browser nowadays. Very many examples, and of course documentation, and you can download the library. I downloaded the library in the same directory that we are working in. And you can see that the app is in this Three.js -dev directory, and then I'm including from it only a few components. So I'm not including everything possible, but just some things that get it to work. And we start off seeing this initial application here, what I have source code written for, and you see two lines, a red line and a green line. So this would be x-axis and y-axis here, and there's actually also a z-axis if I rotate the screen. So if I use my mouse to rotate the screen, I can do that without very much math, because I use this library. I can also use my right click to pan the screen, and I can use my mouse wheel to zoom in or to zoom out. So this is what the library calls the trackball controls. So I'm using these controls from this library to make something that I can interact with easier and without implementing all the code by myself. Now, I'm not going to go through all the code. Some of it you can read by yourself, because this course is not about this 3D stuff, but your project may be. If you're interested to do a more atypical projects, because in the past most of them had to do with maps or whatever, here's your chance to try something more different. So I have some global variables, the radius of the Earth in kilometers, coordinates of tools near me and Dubai. And then in our main function, many things are happening here. The scene is set up. There is also a camera where you get where the view comes from. These controls are linked to the camera, so somehow the camera actually moves when you're playing with the controls. So zooming in means camera goes closer or something like that. Renderer, to render something means to transform something from numbers, from just coordinates and whatever, into something that you see. So it needs to exist there to display anything. We have a function here on window resize, so this just means that every time your window is going to change, it's going to keep the Earth somewhere visible. And all these other functions, we will look a little bit in some of them, but more or less there are some parameters I put for the trackball controls so that it doesn't go too fast or too slow. You can check them out. Also something about the background color. Some things are really easy, like background color. If I want to have a blue background color, I'm just going to do that. And now most likely this blue axis is going to disappear because it's the same blue as my other things. So yeah, be careful with that. But yeah, I'm going to leave it back to white. And I don't talk more about this. The draw axis function is something I wrote. So it's called here draw axis, and it's getting a scaled value of the radius as a parameter. So the radius is 6,000 kilometers there. I'm not going to be able to show 6,000 kilometers on my screen. So I scale it with the function that I wrote here. It's just a linear transformation. Whatever it is, it's going to linearly transform it in a way that it fits into the screen. I also have a scale point function that I wrote, which uses this scale value for each of the x, y, and z. So we will use this later. If I have one point and I want to make it all its components larger, I can use this. So it's not actually larger, it's the real point, like wherever tools near me is going to be, it needs to fit in the same transformation to be visible in the screen. The draw axis function looks like this. It uses a material, so anything to be visible needs to have a material in 3D. The material has a color. It has a red color here, so you probably can figure out that I'm going to draw the red axis, the x-axis. The geometry has 2 points, 2 vertices as they are called, and they're actually called vectors in 3D, in 3 dimensions. Now maybe you know a little bit why I want to use the term vector and not point in VVD course, because it's everywhere. So here you draw a line from 0, 0, 0 to the scaled radius, whatever the value is here, 0, 0, and this is just copy-paste code. You shouldn't do this, but I did. It's almost the same, but the color changed to green, and then instead of length being on the x-axis, it's on the y, and here it changed to blue, and it's on the z-axis. But other than that, this should be a separate function saying draw line, and it should have parameters something like from, to, and a color. And then this code becomes almost 3 times less. But the reason I put it like this here is because I was in a rush, and also because I'm not going to draw any other lines in this application. So this function would only benefit here from modularity point of view. Okay, so this is what the axes are doing here. So 3 axes, and the trackball controls allow me to interact with the environment quite nicely. So now what I'm gonna copy again is a function to draw a sphere, because I want to speed up this lecture a little bit. But I will still explain it. So this function will draw a sphere at a given location with a given radius and a given color. You can see the sphere geometry object from here has 2 strange parameters here. We will get into it soon. And then a material that just has a color, and I'm putting it at a given location, a location given by the parameters there. I'm adding it to the scene and I'm telling it to render. So if I call this function here, scale sphere at the location, well, let's just put it in the middle of the screen. Give it a radius, the same radius we gave to the axes, so it's just going to be around the axes. And then a color, let's say gray. I refresh the page, and I have a square. Okay, interesting. So this square comes because we have the value of segments set to 4 here. It's going to be the number of segments in the latitude and in the longitude. In the longitude and in the latitude direction. So if I were to put here, for example, 50 segments, but 4 segments on the other direction, then I'm going to get something like this. Some strange thing, I have 4 segments here, but here it already starts to look like a circle. It's a bit hard to see without shadows and other things, but I don't want to complicate the code too much. But what we are going to do is just put here a value like, let's say 64. And now this is going to look actually pretty much like a circle because there is no texture yet. Okay. So now the part begins where I teach you a little bit about texturing, and I also want to teach you something else which is not that important maybe yet, but it will become soon because I do expect your projects to look good. So you will need some kind of graphical skills as well. I don't want to teach any other software today, but I'm going to show you how you can make some simple graphics in PowerPoint. I don't ask more from your projects than that, but PowerPoint is actually surprisingly good at doing graphics, but people are just not really using it for that purpose. So I'm going to do something thematic today, because it's, well, let's see what happens. So I'm going to draw some line here, and I'm going to make it really, really thick line. Okay, I need to make it much thicker, so I'm going to go to this format shape, and I'm going to put the width to, say, 70 points. I'm going to color it into some light orange, and from here I'm going to add soft edges to it. So I'm going to more or less make it a little bit blurry like that. Okay. Now I'm going to hold Control down, and when I hold Control I actually duplicate whatever I'm dragging on the screen. It's a nice little trick here that you can do. But I did a poor job, and yeah, and I would maybe like to align these things a little bit better. So I can select everything on the screen with Ctrl A, and if I hold down Shift, I can deselect now this square from behind, so I just have all the lines that I drew. I align them to middle, and I distribute them horizontally. So this spaces them equally around the stage. Now I take this triangle from here, and I'm gonna do some triangle here. I make it black, and I make another one here, and I make another one here. And now I'm just gonna draw this kind of free-form shape. Which I'm going to also color in black and remove its outline. So it didn't take that much, but if you know other graphical software, please use them. But this is somehow, I mean, your projects are not going to be really nice if your interface is going to be text or something really boring. I'm grouping now all the objects and aligning them a little bit better in the stage. I select everything, I copy it, and let's see if I can paste it in Paint. Because, okay, it actually works. Because I want to eliminate these borders there. Okay, and I'm gonna save it in pictures as pumpkin. Okay, pumpkin PNG. Now I go on my server where the demos are, and in the images I already have the equirectangular ones that we're gonna use soon, but just because it's Halloween, I thought that maybe this is nice. It has an educational purpose too. So now we're gonna put this Halloween pumpkin over the sphere, okay? So to do that, I'm gonna need to load a texture here before I draw the sphere in gray, and instead of putting gray there, I need to give it a texture. So my texture is going to be loaded like loader equals to new 3 texture loader. So it's a function from the Three.js library. And then I'm gonna call load from the images directory the pumpkin.png. When it loads, I need to give it a callback function. So this function will trigger when my texture has loaded. And it's going to be made available from the parameter of this function. So texture here, and now this texture I can use it inside here. So what I'm going to do is I'm going to take the sphere, I'm going to draw the sphere, but I'm going to add also the texture to it as the parameter. And in the draw sphere function, I need to modify it to give it a texture parameter at the top. And here, in addition to color, I need, it's called, the object property is called a map. I need to set it to this texture. And maybe this works already now, I hope. I don't really work with this very often. Okay, it works, but I think that this gray has some effect to it. the color from here. So I set it to gray. I think that the white is going to not darken it like this. Okay, so now it's beautiful. But you learn already something here because my lines were parallel. I mean, I just drew parallel lines there. But you see how now it starts to look a bit like the orange shape. So this is in reverse what happens in the texture, in the projection phase. Okay. Now, just a little bit talk more about these other functions. There are many crazy things here, like the ambient light is something you can play with. So you could make, for example, the ambient light be red instead of white, and then refreshing this will look like that. Quite interesting. But anyway, so you can see that the library is quite powerful. It can do many things that would just take very much effort for us to do. But now, I'm enough playing. I'm going to replace it. Instead of using the pumpkin here, I leave the pumpkin commented out if you want to play with it. I'm gonna put the rectangular tsot png apparently. Now it looks like this, but refresh the page. The picture I loaded is this. So same thing, these vertical parallel lines are actually now meeting at this one point. The circles on this sphere that I can rotate, even though they were very flattened here, they reshape back to a circle. And even this very long rectangle on the top side of the map here becomes a circle. It's a slightly blurry circle from here. Okay. Now, we have something that kind of looks like the Earth. We can get it to look even more like the Earth if we replace it with my other picture from here, which is the same thing, but by the way, all of these I took from Wikipedia. So if I replace it with this one, well, it looks like that. So shouldn't be that surprising anymore. But I prefer it to have some more realistic image here. Okay. Wow. Okay, let's go fast because this is taking very much time. So now I want to draw a sphere where Tuusniemi is. But I just know Tuusniemi in these coordinates, so I need a function WJS to XYZ, so that I can put it in the XYZ space. So that means that I need this, whatever the location is going to be here, and the radius, let's call it big R like in the slides before, and my returned value, the XYZ format, I initialize it with 0, 0, 0 and return it. But now you have to tell me the formulas. So what was the value for Y? Yes.
Sine of alpha.
Sine of location dot lat, because this is how I called it here, but yeah, that was our, I think I used alpha twice by mistake, but yeah. So location dot latitude
Times R.
times R. Now, this would work if you are a human, but it expects radians here. So to transform something into
pi times degrees over 180 degrees.
Thank you. So I need to do this before I call the sine function there. Now, what was the small r?
Cosine of alpha times r.
So the same thing but with the cosine.
Yeah.
And then how about the value of x?
Sine of beta times r.
And z?
Cosine of beta times r. Small r.
Ah,
Sorry.
yeah, okay, small r there.
Yeah.
Okay, so now we have WJS to XYZ. So if I say tuusniemi is equal to WJS to XYZ of the big global variable that I did there, I get XYZ coordinates for tuusniemi, and I could put, for example, a small sphere that doesn't have a texture, but maybe it's red, and the radius, let's just put a small radius like 3, but the location is gonna be at tuusniemi. So hopefully this is gonna put a red small sphere at tuusniemi, but okay, this WJS to XYZ expects the radius as a parameter also here. Okay, let's hope this works. I refresh the page. Doesn't work. Console says nothing. Let's try to debug. So I'm going to try to call WJS to XYZ in the console here. I'm getting values. They look more or less correct, but they are not scaled into my space. I need to use that function that I didn't talk too much about it to bring it from somewhere very, very far away, 6,000 kilometers away. Still doesn't work. Okay. So I'm going to copy this code. So tuusniemi value is calculated here. Scale value, I'm sorry, it's not scale value, it's scale point, because radius is a value, but this is a point. So I remind that the scale point transforms all of them, all of the XYZ components. So scale point tuusniemi. Yes, and tuusniemi is not here. Okay. Now this is an interesting reason why it's not here, is because our initial map that we have loaded from here does not start at 0, 0. There is an offset problem here. So, as you can tell, this map, somebody decided to start it somewhere else. But it could really start anywhere, because it just continues again and again and again. I could fix this problem if I would crop it, for example, like this. Now you could also ask something like, why people decide to not crop it like this? Because starting at the 0 at the prime meridian would make more sense for practical use. But the reason I think could be political or whatever, but in general you don't want to look at pictures that have almost nothing in the middle. It's an ocean. So one objective reason why the map looks like this, why we always see it in this way, is because it has more content in the middle and not just ocean. So to fix this problem, I'm actually going to translate the texture, and I know the value of the of the amount that I need to translate it is actually, how do I do this? Rotation, it's on the y-axis, and it should be minus Math.PI divided by 2. So 90 degrees backwards somehow. I'm gonna refresh the page, and now tuusniemi is where tuusniemi is. Okay, so many small things. There's some error that the library that I'm using from Three.js is old. It would go away if I use the new one. Yeah, so that's tuusniemi, great. Let's put also Dubai there. So I'm gonna copy this code. I'm gonna say here Dubai, and make it green. No, I'm gonna make it blue. Okay, it seems to work. So a little bit of testing here, but anyway, it seems to work. So I'm not going to do much more. I'm just going to implement the Euclidean distance and the haversine distance, but I'm going to display the coordinate, these distances just as text. So nothing like drawing curves or whatever. It's out of the scope of this lesson. So the last thing, the Euclidean function, and P1, P2, P3, these are in x, y, z coordinates. So I have square root of sorry, 2 points, but they have three dimensions. Okay. So this one squared plus this one squared plus this one squared. I just wrote it in a different way because it's possible.
Z. There's another Z.
Here.
Yeah.
Thank you. All these things are horrible to debug. It's just a reminder that it's possible to use the power function from the math library. Okay, so we have the Euclidean distance, and now for the haversine, I'm going to need your help again. So haversine, we are going to calculate it between 2 points in let's keep it in WJS, because typically that's how you call the haversine function. You call it for 2 degree polar coordinates. So 2 values there. What we have to do first is actually get the x, y, z values. And then let's use this one as alpha. So alpha was
2 times arcsine. of E over 2 all over R. I don't know who E was.
All over R.
Yeah.
Radius.
Yeah.
It's okay, we use the global variable radius here. So E divided by 2 was on top. E was the Euclidean.
Yeah.
So E is actually Euclidean of P1 and P2. Alpha is 2 arcsine of E divided by 2 divided by radius. I guess it was okay.
Yeah.
And
The
we
distance.
need to, yeah,
Okay, so if we simplify 2, but it's alpha times pi times R over 180.
alpha times.
Because it was 2 alpha times pi times R over 360, and if we divide by 2 both sides, it's so alpha pi R.
So alpha times Math.PI times R.
Radius, yeah.
Radius, yeah.
Over 180.
Over 180.
Yeah.
Okay, I think that this may be enough. Let's see how it goes. So I'm going to save the file. I'm not going to do anything else, so the functions exist there. I'm just going to calculate what is the Euclidean, okay, 2's equal to WJS to XYZ of 2's near me and radius.
Yeah.
Okay. Okay, this is. I don't remember how to make this thing go more up.
Spam enter.
No. I want to open the search.
Sir, you forget the semicolon in the code.
I'm sorry?
You forgot the semicolon in the code.
Yeah, less semicolon for distance.
After 180.
Semicolon. I think it wouldn't complain, but what I did forget is to return it.
Yeah.
So thanks. I think JavaScript is too permissive for its own good. It would not have complained about that, but it, yeah. Okay, I'm not sure. Okay, from here I can open this search field, and when it opens, it forces this console to be more on the top. I wanted this because in your answer you can't see very well the bottom part of the screen. So doing it again, getting 2's near me, Dubai. And now Euclidean between 2's near me and Dubai is, I have to say I think it's correct, because if the radius is 6,000, then this being 4,000 something seems reasonable to me, or in a straight line. But let's see the haversine, because it was in such a rush.
Yeah.
So this one is actually 2's near me and Dubai. I don't need the converted values, and I'm getting not a number. Okay, it shouldn't give me that. So let's see. I have the values. The Euclidean value is here. Arcsine of that divided by radius. So that's the angle here multiplied by pi radius. Okay, teaching you more. So I'm gonna do again this, click on this haversine. Nothing happens. Type haversine. I get my function here, I click on it, and I go to the code. And when the code is visible here, I can click these numbers on the left and set the breakpoint. And now, if I go back to the console and I call my haversine function on Tuusniemi and Dubai, code will stop in this function, and I can see step by step what the problems may be. So I move one step, P1 becomes not a number.
Why?
I don't know. I don't know. I try again. I try again, but now instead of, oops, sorry. Instead of pressing this button, I press this one to go inside the WJS to XYZ function from here. So I go inside here. So my location looks good. The radius is missing. So I am not giving here the radius. This should be really a global variable if we plan to just use coordinates on the surface of the Earth. But if we would like to put our points into space, then not keeping it as a global. So hopefully now it works. I hope. Refresh the page. I eliminate the breakpoint for now. Okay, 80.
It should be like more like thousands.
Yeah, it should be like thousands. So I may fix this offline, but okay, let's try one more time to see what is happening here. I put the breakpoint again. I call it again, and now what does P1 become? So P1 becomes something reasonable, and P2 becomes something reasonable. The E value, so the Euclidean distance, this is the one we thought is reasonable before.
Yeah.
Yes. Okay. But then alpha, so how much is this alpha? 72.
0 points. Should that be degrees?
No, this is not.
What was an angle?
So it's in radians.
Yeah, I think it's in radians, but do we have an error here? So 2 times arcsine of e divided by 2 divided by the radius. I think that this should be
Right.
correct, yeah. This is correct. But then the distance, so this alpha multiplied by, oh, okay. Here in my notes, this is different. It's actually multiplied for some reason by 2 times the radius. No, just by the radius.
Without pi?
Yeah. And without dividing but by 180. Did we make some kind of...
I think you need to separate math.pi with radius. Otherwise it is saying math dot, I don't know.
So in my notes here, I have Math.PI multiplied by radius, and so not dividing but by 180, and then
Times 2?
sorry.
Times 2 on top of that? Or?
So we have the 2 there in the angle. I have a little bit different nodes
yeah.
here. So I think it's just like this.
Yeah.
But I don't know if we made a mistake on the board before. We have to check, but I think no. I think the pi actually simplifies. Before. Yeah, anyway, let's fix it like this and see if the values become more reasonable now. So, nope.
It's too much.
Yeah. Could be double or something. Okay, we definitely made some mistake somewhere.
Yeah.
But
Can it be that the fact that we use like degrees in the last equation, or should it stay the same?
we used,
It's not there anymore.
yeah. Okay, I'm a little confused and I don't want to go back to see why. I mean, time is ending also, so. I think what we will do is I will check the video and I will post some correction, like whatever the problem is, I will put a link to it